Hey everyone, I'm Nick, and this is my foam application discussion. Firefighting foam is used in fire suppression methods that have been used as a firefighting medium for flammable and combustible liquids. It is a stable mass of small air-filled bubbles that have a lower density than oil, gasoline, or water. Foam has three major ingredients in it, which are water, foam concentrate, and air. Mixing these three ingredients can form a blanketing and cooling agent. Foam systems are equipped into fire apparatuses to allow operators to dispense a specific amount of foam that can be mixed with water. Firefighting foam can be especially useful in extinguishing fires that involve flammable liquids or gases, petroleum, tar, oils, solvents, or alcohols. These type of fires would be classified as Class B fires. Its primary role is to cool the fire and coat the fuel. This prevents the involved fuel from making contact with oxygen, therefore suppressing the overall combustion process. The chemical composition of foam helps break down the water surface tension, which allows water to penetrate through any burning material. This then makes water work more efficiently in the extinguishment process. Mixing foam with water also forms a film that can hover over the spill site or the burn site or the burning liquid itself. This then seals the flammable vapors. So firefighting foam can prevent vapor production and ignition. It suppresses the blaze while also stopping it from spreading or reigniting. There are a variety of methods that foam can be applied. Some examples include the rain down technique, the build on technique, and the bounce off technique. The rain down technique is performed by spraying the hose stream into the air and letting the foam gently cover the surface of the burning product. The build on technique uses the ground surface of the burning products as base. The foam will then accumulate and move across the affected area. The bounce off technique is somewhat similar to the build on technique, but instead it utilizes vertical or elevated surface to allow the foam to build onto the burning product's surface. Those that plan to use this method, they must keep in mind that introducing air into the stream will reduce the overall effective range. Other considerations when using foam on a burning product are that they must be controlled, and the foam has to be applied in a manner where the fuel is not splashed around, because this could possibly spread the fire even more, which would prolong the overall extinguishment process. Lastly, operators should maintain the foam's blanket integrity throughout the whole extinguishing process. Now, moving on to how foam applications can suppress fires. As mentioned before, foam can smother and cool a fire. The three elements of the fire triangle is heat, fuel, and oxygen. The foam blanket can blanket the fuel surface of a fire, which can then separate the ignition source from the fuel. The foam blanket can also limit the release of flammable vapors that can mix into the air. This then displaces oxygen and the fuel making contact with these vapors from the process. Eliminating one of these elements can then lead to the fire getting extinguished. Foam can also act as a cooling agent, which would remove the heat out of the combustion process. Reducing the temperature from a burning material will reduce the overall heat release rate, therefore, again, extinguishing the fire. So looking back at the information presented, I can see why foam can be an effective alternative for extinguishing gasoline or diesel fuel fires. Thank you for listening. Have a great day.